All right, and hello everyone. Hope you're having a good day so far. I'm going to go over the solutions for the Algebra 2 review for section 6164. Today is Wednesday, April 8th, and I'm posting the review today. Tomorrow, April 9th, I'm opening up the quiz. It is not due until the 14th, but it is going to be open for you to take anytime during that slot. It will be a 2-hour time limit. So as soon as you start, you have 2 hours to do it. I don't expect you to take that long, but I don't want to give you guys, I don't want you to rush through it. It's all multiple choice. You will not know your score. It will not tell you if your answers are right or wrong, like the ticket out the door quizzes have been, because those were practice. This is the actual assessment. I will grade it myself, and at midnight on April 14th, the test will lock. So if you haven't taken it by then, you're going to have to get in contact with me, or I'm going to get in contact with you about what we can do. After April 14th, I'm going to send you a copy of the quiz. And if you got anything wrong, you can look it up and you can make test corrections to it. And if you feel like you could have really done better, then I will have prepared a second quiz by then that you can do. In the meantime, we're still going on with the lessons. 6.5 will be posted on Monday, and so on. I will be available online tomorrow during class time to go over this review. I will also be online Tuesday to go over the review. And if you want any other review, let me know. I can do a one-on-one with you. And I'm also making this video, so hopefully that'll cover all the bases. By the time you're done with this, you'll know what's going on. All right, let's get to it. First question. There's 13 questions in this review. The first question is multiple choice. If you're given that from the function of f and that for the function of g, what is f plus g? Well, remember, f plus g is just what you think it is. You're only adding them together. So if you do f plus g, all that it is. Here's f. Here's g. You're adding them. And of course, simplify it when you can. This is the only x squared. We have 3x plus 2x, which is 5x. We have negative 5 or minus 5 plus 1, which is negative 4 or minus 4. So we have x squared plus 5x minus 4, which is this one. All right. Number 2. Now we're taking these functions and we're dividing them. So if we're dividing them, we're going to take f divided by g. F is this. G is this. Now it says that x cannot equal 1, because if you do 1, you get a 0 on the bottom, which you can't do. We're going to deal with that stuff in further courses, but not this one. You just cannot divide by 0. Now you notice it doesn't match any of the answers, which means we can factor the top. Now use your skill. Oops, I don't know why I put that in parentheses, but that's okay. You have x minus 1. That means one of these things to factor on top is probably x minus 1. So can you think of two numbers to multiply to be negative 4 and add to be positive 3? So that would be positive 4 and negative 1. 4 minus 1 is 3. 4 times negative 1 is negative 4. Here we are, and then what do you notice? Those will cancel. You're left with just x plus 4, which is this one. All right. Number 3. So we have f defined as these 3 points, g defined as these 3 points. We're finding f of g. Remember, that's not a multiply. It's a circle. That means f of g, which really means this. So we're taking our g values and putting them into f. So does f of g exist? So let's start with the g. What is g of 8? Well, g of 8, according to this, is 2. Well, we're going to put that value of 2 in there. Do we have an f of 2? Well, there we go. F of 2 equals 3. So we started with 8. We ended up with 3. All right, let's do the next one. What's g of -1? If we plug -1 for g, we get an answer of 4. All right. So what's f of 4? Is there an f of 4? Sure enough, here it is. F of 4 is 8. All right. So if I start with a -1, I end with an 8. And lastly, they all have to work for this to be true. I'm going to find g of 2, which is 7. All right. So let's put that 7 in for f. And I'm guessing that we're going to have an answer. And sure enough, f of 7 is -1. So if I start with 2, I end up with -1. This would be our f of g function. And let's see if we've got that. Do we have an 8, 3? We have a -1, 8. We have a 2, -1. Here we go. Choice B. Number 4, the x-intercept of the graph. So remember, an x-intercept is where it crosses the x-axis. So anywhere along here where it crosses, we got to figure it out. Well, all I want to know is when does y equal 0? Now, if you think about it, what's the square root of 0? It's still going to be 0. We just got to figure out when 2x plus 1 equals 0. Or the other way to do it, what's the opposite of the square root? It's the square. If you square both sides, the square of the square root is 2x plus 1. The square of 0 is 0. Sorry, it's a meeting I'll be going to in a few minutes. You'll never know the time, though, because I'll be editing that right out. All right. Or maybe I won't. So subtract 1 from both sides, then divide by 2. So x is -1/2, and that would be your x-intercept. All right, number 5, moving along pretty well. The domain. All right, the domain. Remember, the domain is what you can put into the graph. So it's a bunch of x values. X, x, x. Okay. So what do you got to be careful of? You cannot take the square root of a negative number. And what's the boundary between negatives and positives? Well, it's that great number 0. So let's do it this way. What gives us a 0 answer? All right, subtract 9 from both sides and divide by 3. Right? Subtract 9, subtract 9. So that's our starting point. You're going to notice it's going to be A or B. Can't be these two. So if you put a -3 into there, you're going to get 0. Which is fine. 0 works. 0 is a number. Okay, the square root of 0 is 0. We need everything that's positive now. So which direction are we going? Do we want numbers greater than -3 or less than -3? So it's up to you to figure that out, and that's not a hard thing to figure out. What if we just tried a number like 5? If I put 5 into here, do I get an answer that makes sense? Well, 3 times 5 is 15. 15 plus 9 is 24. Is the square root of 24 a doable number? And that's yes. So we need all numbers from -3. Whoops, let's do it this way. We need all x values that are bigger than -3. Oh, and I didn't even notice it. Look, there's a 3 and a positive, -3 and a +3. We knew it was A right away. Some of you guys are probably there. Look, it's -3. Sorry, I missed it. Okay, A is the correct answer. Number 6, the cube root of 216 x to the ninth. Well, multiple choices tend to lead you in the right direction. I'm guessing the cube root of 216 is 6. 6 cubed is 216. And just what do you do with the exponents? So the cube root of 216 is 6. So remember, that's where this comes from. The cube root of 216 is 6. Now, what about the x to the ninth power? So remember, if we're escaping from radical jail, they have to come out in groups of 3. How many groups of 3 do we have? We have 3. Or in other words, what is 9 divided by 3? So 9 divided by 3 is 3. So we have x cubed. Okay. That's what comes out of there. So the whole answer would be 6x cubed, which gives us the answer of J. Now it's not plus or minus 6x cubed because we're not, a cube root doesn't give us an option of a plus or a minus. A cube root is just a cube root. All right, number 7, square root. Well, let's do each part separately. Square root of 4x squared y squared z to the 4th. All right, square root of 4 is 2. Square root of x squared. How many pairs of x's do we have? Remember, there's a 2 out here, but we don't write it. 2 divided by 2 is 1. 2 divided by 2 is 1. 4 divided by 2 is 2. So our answer is 2xyz squared. 2xyz squared. There it is. Okay, now plus or minus again. It gives us a positive answer. Okay, square roots always give you a positive answer. All right, non-multiple choice. Let's zip through these. So f minus g and f times g. Okay, well, f minus g is going to equal, here's f, subtracting g, which is 3x squared. There it is. You're technically done, but we like to put them in order. So that's f minus g. And technically I should write it like this to make it more accurate. Okay, now what's f dot g? That means times. It's not an open dot. It's not a composite. It's f times g. So f times g. So f is 4x minus 9. G is 3x squared. We're just multiplying them together. So distribute both of these times that. So 4x times 3x squared is 12x cubed. And then negative 9 times 3x squared is negative 27x squared. And that is f times g. Again, we should put them in parentheses. So there's f of g. There's f minus g. Okay. How you doing? Doing okay? Sometimes when you do these things in parts, they're a little bit trickier. But when you put them all together, you see how it all flows. Sometimes it's not as bad. All right, here's composites. F of g, g of f. So this makes it a little bit trickier. Remember, this is what f of g means. We're putting g into f. So f is 4 times something minus 9. Well, what is that something? That something is g. And what is g? G is 3x squared. And then simplified if I can, I just multiply that out. 12x squared minus 9. That's f of g. Okay. Now g of f is where we put f inside of g. G is 3 times something squared. Well, what is that something? That something is going to be 4x minus 9. right, we're going to multiply this out. Now, if you remember the shortcut for squaring a binomial, we're going to do it that way. Could you do 4x minus 9 times 4x minus 9? Do it that way? Of course you could. But let's do a little shortcut. So we take 4x and we square it. We multiply these two together and double it. 4 times 9 is 36. If we double it, we get 72. And then negative 9 squared is 81. So we just zip this in there. Let's see. 16 times 3 is 48. 72 times 3 would be 216. And 81 times 3 would be 243. So that is what g of x equals. All right, let's move on. A couple more to go. What's the inverse of 4x minus 8? Now what I'm going to do is I'm going to write that p of x as a y, because that's what it is. It's the y-axis. So to get an inverse, we flip them, and then we solve for y. So I'm going to add 8 to both sides. Then I'm going to divide by 4. So I'll put that over here. X plus 8 over 4 equals y. Now it's a good way to write the answer. I always, of course, like writing the y first. And I like to, this is me personal, I don't like to leave it like a fraction like that, but there's nothing wrong with it. I divide each thing by 4. So it'd be 1/4 x. 8 divided by 4 is 2. So either of these are correct. And they'll both be fine. Okay. Calculator to approximate the 4th root of 287. Well, hopefully you have a calculator that will do that. If you don't, let me know. I'm just going to put it on my TI-84 here. I'm going to do math. I'm going to pick number 5. I'm going to put a little 4 outside for the root and a 287 on the inside. And that just gives me 3 decimal places, 116. You know, there's not much brain power there. You just put it in there and see what happens. All right. 2 more to go. We're going to graph this and graph its inverse. Okay, the function is 4x minus 2. Well, let's graph 4x minus 2. 4x minus 2 means we start 2 below, and the slope is 4. 1, 2, 3, 4 over 1. So that will be our graph. Let me just draw, let me grab a line tool. And, all right, let me fix this. Let me stretch these out. All right, there's 4x minus 2. Now it's inverse. So remember, if y equals 4x minus 2, let's just switch them. I'm going to add 2 to both sides. I'm going to divide by 4. I'm going to just write it like this. Now, you might be thinking that has a slope of 1/4 and it crosses the x-intercept at a half. That's not as easy to graph. So I think in this case, I'm just going to pick some points just to make it easy to graph. I know it's a line, because if that's a line, its inverse is a line. Let me pick a good value for x, something we can divide by 4. Well, if I pick 2 for x, 2 plus 2 is 4. 4 divided by 4 is 1. There's a good point. Let's pick another one. What else can I divide by 4? I can do 8 divided by 4, so that x has to be 6. I'm not sure if that's on the graph, but we'll find out. 6 plus 2 is 8. 8 divided by 4 is 2. 1, 2, 3, 4, 5. Well, it's almost on the graph. Let's pick one that's on the graph. How about negative 2? What's negative 2 plus 2? It's 0. What's 0 divided by 4 is 0. So we got some good points here. So here's 2, 1. Here is negative 2, 0. And that's enough. We know that 6, 2 is out here. 3, 4, 5, 6, 2 is out here. All right, let's draw that graph. Let me pick a different color for that one. Maybe we'll do that one in red. Okay. There we go. Let me just fix that line. There you go. That's the graph and its inverse. Determine whether these two are inverses. I'm going to show you both ways. The first way is if I put, whoops, try that again. The first way would be if I put f inside of g, I should end up with the same value. So if I put x inside, I should end up with x as an answer. So I'll show you how that works. So g is 3 times something minus 6. Okay? I gotta go real soon. Well, that something is 1/3 x plus 2. So if I multiply this out, what happens? 3 times 1/3 is 1. 3 times 1x. 3 times 2 is 6. And then minus 6, I end up with x. That shows it's an inverse. The other thing you could do is actually find the inverse. So let's say we just do that. So let's say we have 3x minus 6. All right, and I actually do the inverse. Solve it for y. Let me add 6 to both sides. And then let me divide by 3. Now you're going to notice that's not what we have. We don't have x plus 6 over 3. But what's x over 3? Well, it's 1/3 x. And what's 6 divided by 3 is 2. So I think you'll see 1x plus 2, 1/3 x plus 2, 1/3 x plus 2. So that's how you know. There is my quick little review. And if you have any questions, let me know. I will be online tomorrow, on Thursday, and on Tuesday to go over any questions that you might have with this. And the quiz will be ready to go starting Friday, and it is due on Tuesday the 14th. So I gotta go to my meeting, and I hope you guys have a great day.